Hello everyone, how are you all? Today I am here to discuss your chapter 15 of NCERT, which is probability. In this we will discuss about what is probability and how to find out probability through formula also. We will do questions based on probability also. In everyday life, we come across statements such as, "It will probably rain today." "I doubt that he will pass the test." "Most probably, Kavita will stand first in the annual exams." "Chances are high that the prices of diesel will go up." "There is a 50-50 chance of India winning a toss in today's match." The words probably, doubt, most probably, chances, etc. used in the statements above involve an element of uncertainty. For example, probably rain will mean it may rain or may not rain today. The uncertainty of probably can be measured numerically by means of probability in many cases. In your earlier classes, you have already had a glimpse of probability when you performed experiments like tossing of coins, throwing of dice, etc. and observed their outcomes. You will now learn to measure the chance of occurrence of a particular outcome in an experiment. For example, take any coin, toss it 10 times and note down the number of times a head and tail comes up. For example, you are tossing it 10. Each toss of coin is called a trial. So, a trial is an action which results in one or several outcomes. The possible outcomes in our activity was head and tail. With this background, let us now see what probability is. Based on what we directly observe as the outcome of our trials, we find experimental or empirical probability. For example, take any coin and toss it 10 times and note down the number of times heads and tails comes up. Like number of times coin is tossed, it is 10. Number of times head comes up. Let's take out of 10 heads comes up 6 times. Then number of times tail comes up, let it be 4. Now, after writing down this, find out the fraction number of times head comes up upon total number of times the coin is tossed. In this case, number of times head comes up is 6 and number of times the coin is tossed is 10. So, it is 6 by 10. Similarly, now also note down the fraction for number of times tails comes up upon total number of times the coin is tossed. So, in this case, number of times tails comes up is 4 and number of times the coin is tossed is 10. So, we have got 6 by 10 and 4 by 10. Experimental or empirical probability, let us give the notation as probability of E as experimental or empirical probability. It is equal to number of trials in which event happened upon total number of trials. Let us take an example. Suppose a coin is tossed 1000 times with the frequency. Now coin is tossed 1000 times with the frequencies head is coming 455 times and tails is coming 545 times. Find out the probability of both the events, that is head and tails. So, probability of heads. What we said, number of trials in which event happened means how many times heads is there. Heads we have got 455 times. So, that means 455 upon Total number of trials. How many total number of trials are there? A coin was tossed 1000 times. So it is 455 by 1000. Similarly, they said find out the probability of tails also. So what is the probability of tails according to this? 545 upon total is 1000. So 545 by 1000. You can also observe that probability of head plus probability of tail. 455 upon 1000 plus 545 upon 1000 is 1000 by 1000, which is 1. So we have observed probability of heads, probability of tails. These were the only two outcomes here. So probability of heads plus probability of tails we have got is 1. Now let's take one more example. Two coins are tossed simultaneously 500 times. Now we have got two heads 105 times, one head 275 times, no head 120 times. Find the probability of occurrence of each of the events. Means we need to find out the probability of two heads. Let's take two heads as event 1, one head as event 2 and no head as event 3. So it will be easier to write down. Probability of E1. E1 means two heads. So how many times two heads occurs? It is 105 times. 105. What is the formula? Number of times the event occurred upon the total number of trials. So 105 upon total. How much is the total? 500 times. So it is 105 upon 500. Similarly, probability of E2 means one head 275 upon total is 500. Similarly, probability of E3 means no head. How many times no head is there? 120. So it is 120 upon total is again 500. You can do the simplification also, means 105 by 500 means it is 21 by 100. Similarly, 275 by 500 means 55 by 100. 120 by 500 means 24 by 100. You can further simplify it also. We can further simplify it. Dividing by 5, it will be 11 by 20 and it will be, you can further simplify on 4, it will be 6 by 25. But it will be easier to show the addition in this if we will leave it like this. Now what we can show is probability of E1 plus probability of E2 plus probability of E3. These are the only three events. E1 21 by 100 plus E2 55 by 100 plus E3 24 by 100. Now what you can check is after adding, if we are adding all the events, your answer should be 1. Now check whether you are getting it 1 or not. 55 plus 24 plus 21. We have got 100 by 100. So your answer is 1. So we have shown that sum of all the probabilities is equal to 1. Let's take one more example. A die is thrown 1000 times. Now note down the outcomes and its frequency. Like number 1 is coming 179 times. Number 2 on a die is coming 150 times. Number 3 157 times. Number 4 149. Number 5 175 and number 6 190 times. Find the probability of getting each outcome. So let's take every number as E1, E2, E3, E4 like that. Like probability of E1 means probability of getting number 1. So probability of getting number 1. How many times number 1 is there? 179 times. So it is 179 by total. How many times totally we have thrown the die, that is 1000 times. So 179 by 1000. Similarly, E2. E2 means number 2 now. E3, number 3, E4 is number 4, E5 is number 5 and E6, let's take it as number 6. So E2, how many times number 2 occurs? 150. So 150 by 1000. Similarly, probability of E3 means number 3. So number 3 occurs 157 times. 157 by total is 1000. Number 4, E4, number 4 which is 149 times. 149 by 1000. Similarly, number 5, E5, it is 175 times upon total is 1000. Number 6 is 190 times. So probability of E6 is 190 by 1000. Now, these are the probabilities of getting number 1, number 2, number 3, number 4, number 5 and number 6. Now, also let us check that whether sum of all these probabilities is equal to 1 or not. Probability of E1 plus probability of E2 plus probability of E3, E4 plus E5 plus E6 is equal to 179 plus 150 plus 157 plus 149 plus 175 plus 190. Now add all these numbers. What you will be getting? You will be getting it equal to 1000. So 1000 by 1000 we have got sum of all the probabilities is 1. Also you can observe that probability of every number lies between 0 and 1. You can check. 179 by 1000 means 0.179. Similarly, 150 by 1000 means 0.150 and so on like that. So what we have observed from all these experiments, that value of probability always lie between 0 and 1, and sum of all the probabilities, if we are taking all the outcomes, then sum of all the probabilities is always equal to 1. Now let's take an example. A tire manufacturing company takes a record of the tires need to be replaced after covering certain distance. Now the table shows the results of 1000 such cases. Now here the table is given, distance in kilometer is given and its frequency. Like less than 4000 kilometer, 20 tires are replaced. 4000 to 9000, between 4000 to 9000 kilometer, 210. 9001 to 14,000 kilometers, 325, and more than 14,000, 445 tires. Now, find the probability of, means if you buy the tire of this particular company, then find the probability of, first part, it will need to be replaced before it has covered 4,000 kilometer. Now, please check from this table where it is before 4,000 kilometer or less than 4,000 kilometer. So, how many outcomes are there where less than 4,000 kilometer is there? You can check. Less than 4,000 we have 20 tires. So, that means probability of tire to be replaced before 4,000 kilometer is 20 upon total outcomes. How many total outcomes are there? These are 1000 cases here. So 20 by 1000, we can simplify it further. It will be 1 by 50. So probability of first part is 1 by 50. Now, in the second part, they are asking, find the probability that it will last more than 9,000 kilometer. Now, please check from your table, more than 9,000. Here it is 4,000 to 9,000. More than 9,000 means it can be 9,000 to 14,000 also, and more than 14,000 is also more than 9,000. So that means how many tires are there where it is more than 9,000. So more than 9,000, both the cases are there. So that means probability of more than 9,000 is 325 plus 445 divided by total outcomes, which is 1000. How much is 325 plus 445? 770 by 1000 or 77 by 100. So that is the answer for the second part. Now please check for the third part. Find the probability that it will need to be replaced after it has covered somewhere between 4,000 and 14,000. Between 4,000 and 14,000 you can check. It is less than 4,000, so we will not take this. They said between 4,000 means more than 4,000 and less than 14,000. So which two cases will be there? This will be there. Between 4,000 and less than 14,000. So that means these two cases will be there, because here it is more than 14,000 and here it is less than 4,000. So that means probability of between 4,000 and 9,000 is 210 plus 325 divided by total is 1000 only. So how much is 210 plus 325? It is 535 by 1000. So your answer for all the parts we have given by only reading the table correctly. Now let's take an example where again you have to read the data very carefully. For example, an insurance company selected 2000 drivers at random to find a relationship between age and accidents. Like in this table it is given age of the drivers 18 to 29 years, 30 to 50 years and above 50 years, and how many accidents in 1 year they have done. How many drivers with 0 accidents, with 1 accident, with 2 accident, 3 accident or more than 3 accidents in 1 year, with the age differences given like 18 to 29 data is given, 30 to 50 again and above 50 also. Now you have to find out the probability of first part. Now please read it very carefully. Being 18 to 29 years of age and having exactly 3 accidents in 1 year. What they said? 18 to 29. So only we will read this line. 18 to 29, exactly 3 accidents. This is 0 accident, this is 1, this is 2, this is exactly 3. So how many outcomes are there for exactly 3? That is 61. So that means probability of exactly 3 accidents when age is only 18 to 29 years. So it is favorable outcomes or number of trials, which is 61 upon the total. And how many total drivers were there? The data was conducted for 2000 drivers. So it is 61 by 2000. So that means answer for the first part is 61 by 2000. Now second part, what they said? Being 30 to 50 years of age and having 1 or more accidents in a year. They said 30 to 50. Now read this line very carefully. 30 to 50 years, 1 or more accidents. It can be 1 accident, it can be more. More means 2 also or more than 3 also. So that means probability for the second part, let us take it as E2, second event. It is 1 or more, so that means 1 accidents, 125, 2 accidents, 60, 3 accidents, 22 and more than 3 is 18. So that means we have total upon the total outcomes is 2000. Now add all these 125 plus 60 plus 22 plus 18. So we have got 225 by 2000. So probability of the second part is 225 by 2000. Now similarly for the third part, they said having no accident in 1 year. Now in this they have not particularly asked a particular age group. They are asking no accidents in 1 year. That means all the drivers of any age group with no accidents. So how many drivers are there with no accidents? No accident means zero accident. Please check. 0. 18 to 29, 440. 30 to 50, 505, above 50, 360. That means all these are with no accident. So probability of the third event, that means no accident, is 440 plus 505 plus 360, say, divided by the total, and the total is 2000. 440 plus 505 plus 360. 1305 by 2000. So your answer is 1305 divided by 2000. I hope this one is clear to everyone. One more example. 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows. Bag 1, number of seeds germinated is 40. Bag 2, 48. Bag 3, 42. Bag 4, 39. And bag 5, 41. So what they have asked is, find the probability of, number 1, more than 40 seeds in a bag, 49 seeds in a bag, and third part, more than 35 seeds in a bag. In this, they have asked about the bags. So how many total bags are there with us? 5 bags. So that means total bags with us is 5. Now let's write down the answer with the same question only. More than 40 seeds in a bag. In how many bags we have more than 40 seeds? Please check. In how many bags we have more than 40? They don't have said 40. They said more than 40. So here is 41 seeds, more than 40. 42, which is more than 40. 48, which is more than 40. These are 40 seeds only, and these are 39 only, which is less than 40. So that means how many bags containing more than 40 seeds? We have 3 bags containing more than 40 seeds. So answer for the first part will be 3 by total, and total bags are 5. So that means probability of seeds germinated more than 40 seeds in a bag is 3 by 5. Now second part, they have asked 49 seeds in a bag. So in how many bags we have 49 seeds? Please check. First bag 40, then 48, then 42, 39 and 40. We have seen that not in any of the bags we have 49 seeds. So what is the favorable outcome for this? How many bags? No bag, that means 0 bag, upon total is 5. So probability in this case is 0 by 5. Similarly, third part, more than 35 seeds in a bag, more than 35. 40 is more than 35, 48, 42, 39, 41. All the seeds in all the 5 bags are more than 35. So that means answer for the third part is, how many bags more than 40? 5 bags, and total is also 5. So 5 by 5, which is 1. So with all these examples, we have observed that probability of every event will be from 0 to 1 only. It will never be less than 0, never be more than 1. And also we have observed that if we are considering all the outcomes, then sum of all the probabilities will always be equal to 1. I hope today's topic is clear to everyone. So let's do the recap what we have done today. What we have done is, we have done about experimental probability. What was the formula of experimental probability? That was number of trials of the event upon total number of trials. Also we have done different questions based on the probability. Now what we have seen, that the value of probability always lie from 0 to 1 only. It will never be less than 0 and never be more than 1. Also we have done that sum of the probabilities of all the outcomes is always equal to 1. So I hope it is clear to everyone. Please try all the questions of your exercise. Thank you very much.